So, we have our first speaker of the day. Our first speaker is Tohar Braun. Tohar is a research tech lead at Orca Security, where he helps bring cyber criminals to justice, where he stops ransomware from extorting innocents and unveiling numerous security issues for high-profile companies. In this talk, Tohar is going to introduce IAM Ape, which is an IAM AWS Policy Evaluator, open source tool, and it was designed to simplify the process of calculating effective permissions for AWS entities. So please give a warm welcome for Tohar.
All right, thank you. Good morning, everyone. It's an honor to be here. Thank you, Mike, for the introduction. My name is Tohar. I'm from Orca Security. I'm the research tech lead over there. And just a quick note before we start, something I want to get off my chest. IAM in AWS is a mess. Thank you. Thank you. All right, I was gonna go with like raise your hand if you disagree, but we don't need that. All right, a little bit about myself, the gratuitous who am I? My name is Tohar. I've been doing cybersecurity for the past 8 or so years. My formal education is completely irrelevant. If you want to ask me about that, I'll talk about it to no end. And because you need to put your credentials on your who am I, these are my AWS credentials, if you want to grab those. All right, so quickly, what is APE? APE is the AWS Policy Evaluator. Its whole purpose is to show you this little thing, the effective permissions, the sum of all the permissions you have on your user group or role. I do that by basically evaluating all the policies. We'll talk about that in a minute. Why it's such a problem, why it's such a hassle, and why I had to come up with this nifty little tool. But first, let's do a little crash course in IAM for those of you who aren't initiated. Just a couple basic things. It's not going to be super comprehensive. I'm going to be missing a lot of little points. I'm going to be oversimplifying a few things. Don't worry about it. If you want to jump deeper into IAM, that's a whole like 2-hour talk, at least. So you have your users, which are the human interactors with your platform. You have groups, which are a collection of users. Groups are just a simplified way of managing all of your users, so you don't have to attach policies individually to each user. You have your roles, which are your non-human users. Basically all your applications, all of your federated entities, they can be users if they use SSO. I told you I was going to oversimplify things. And you have your policies. You have managed policies, which are essentially resources, which you can then attach to either users, roles, groups, instance profiles, etc. Oversimplification again. And those policies are made up of statements. Each statement is made of crap. Sorry, wait. I meant park. Yeah, it's made out of park. A principle is essential. The principle, action, resource, and condition is basically the who, what, where, and when can perform any action on AWS. The principle is the user, role, group, etc. The action is the specific API action that they can perform, and resource specifies which resource they can perform that API call on. And the condition is a set of conditions, anything from when during the day a user can perform those actions, all the way to who exactly can perform those actions, from which IP addresses, whether they have MFA enabled, etc., etc. There are hundreds and hundreds of conditions. We're not going to get into that. Just again, as an overview of what is IAM. There's also NI or NEN or N, which, however, it's not part of the park, so I had to put another slide for it. It's essentially the effect. So a statement can be either allow or deny. So you can both deny actions and allow actions. You have your not action. So if you specify a not action, then you're essentially including all other actions in that statement. For example, if you have an allow and a not action of IAM asterisk, then every other single action across AWS is permitted except IAM asterisk. You also have not resource, which is the same principle, only in resources. So now that we've gone over that, what's the problem with all that? Sounds simple enough, right? The problem is there are policies everywhere. Take, for example, this user. We'll call him Jim. Jim is a concept. He does not exist. Do not get attached. We'll kill him later. So Jim can have an inline policy. An inline policy is an integral part of the user. You set it up the same way that you would set up the user's email, the username, user password, etc. It's an integral part of the user. You can also attach a managed policy, the one that we mentioned earlier. You can also attach a group. That group can have an inline policy. That group can also have an attached managed policy and another attached managed policy. And all those policies apply to Jim, who is part of that group. Oh, and did I mention he's also a member of another group who also has 3 policies. I forgot to also mention a little thing called permissions boundary, which is a policy which defines the maximum amount of permissions that a user or an entity in AWS can have. Essentially, if an action or an API call is not defined in the permission boundary, then it is not allowed by any other policy. If you define a permission boundary with only a set of those permissions, you cannot grant other permissions to the users. It does not in itself grant permissions to a user or to an entity. It only defines the maximum amount of permissions. Same concept applies to a thing called SCP, which is a service control policy. It is the same concept, only applies to an entire cloud account in AWS. So, given that we now have 8 policies, a permission boundary, and an SCP policy, what the heck are my effective permissions? This is the question that we came here to answer. So, the solution is IAM Ape, Identity and Access Management AWS Policy Evaluator. And if you think that I came up with the acronym first and what it meant later, then you're probably right. How does it work? All right, so we have 4 phases how the tool works. The first phase is we have to collect all of the information. All the relevant policies are gathered through the AWS API called Get Account Authorization Details, which gives you a very long, very comprehensive JSON report of all of your policies, all of your roles, all of your users, all of your groups, all of your permission boundaries, but not your SCP policies. We'll talk about that later. They are optional, and you can either use your regular credentials as long as you have permissions, or you can provide that to Ape as an input. After we've gathered all that information, we've made all the connections of all the users that we want to get the effective permissions for, we've connected all the relevant policies, we then need to expand those policies. Essentially, we take this policy statement on the left. In this case, I've gone with allow S3 get wildcard on the wildcard resource. We expand that into a set of action resource condition tuples. Basically, we have an allow list, we have a deny list, and you have a permission boundary list. As you can see, each tuple is just the specific API action with no wildcards, the resource to which they apply, and whether or not it has a condition. Now we come to the crux of the matter, the evaluation. Each allow statement has to be evaluated against any deny statements or boundary statements that are relevant to that action. How do we do that? Essentially, we have this decision tree, in which we check whether the allowed resource is equivalent to the denied resource. Again, we have the specific API for the allowed action and with the same API call for as a denied action. If those resources match, we deny the action. If the denied resource is a wildcard that includes the allowed resource, we deny it. If the allowed resource is in a greater scope than the denied resource, then we only partially allow the action. So in this case, you can see we have this example in which we had an allow statement which allowed S3 wildcard on the resource, basically on all S3 buckets in AWS, but we also had a deny action for this specific bucket, not this and not these on all those resources. So we've added the not resource part of the statement in order to show that. If you are familiar with AWS IAM, then you know that this is actually not an acceptable syntax for an AWS statement. AWS does not support this type of syntax of having both the resource field and the not resource field. But I felt that it is a simpler, more explainable way of showing you guys that you have permissions for those resources, but not those resources. Instead of having two statements, one of allow, one deny, I felt it was more appropriate, more nice. If we zoom in for a second, we can see that we also have conditions, which we mentioned briefly. But in this case, if we have the allowed action resource and the denied action resource that are equal, but then the deny statement also has a condition, then we have to add that condition into the allow statement. For example, if we had a deny action which had the condition of string equals S3 prefix project, doesn't matter the specifics, but essentially we have to flip that condition from being a positive or negative back to negative or positive. So if the deny statement used to be string equals S3 prefix in the deny statement, then the allow statement has to say string not equals. All right? Follow me so far? Good. All right. So, yeah, I said it was a decision tree. It's more of a decision forest because there's not only allow resource and deny resource, there's also not resource. So we also have to check those conditions where there's an allow resource and a deny resource, allow not resource and the deny resource. So it becomes this whole maze of decision forests, and we also have to account for conditions. As I said, if you want to dive deeper into the code, I more than welcome you to do that. We just don't have the time to go over all of it right here. Oh, and then we come to boundaries. So boundaries can also, of course, have deny statements, and those deny statements act just like any other deny statements, because in AWS IAM, deny trumps everything. If you have a deny statement anywhere, that deny statement wins. So if there is no allow statement within the permission boundary, then we do not allow that action. If the allowed resource is, again, same as the deny resource, sorry, that must be a typo. Anyway, if the allowed resource equals to the boundary resource, then we allow the action. If the allowed resource in the policy is within the scope of the boundary resource, again, we allow. If the allowed resource is a larger scope than the scope that the permission boundary allows, we only do the partial allow, and we add that not resource again. And the allowed if the allowed resource is not the same as the boundary resource, we it should say deny. I'm not sure why it says allow. I'm sorry. And again, it's the same situation with boundary resources and not resources and allow resources and boundary resources. It's very tedious. It took me a while to write this. Thank you for coming. Okay, and now the final phase, we take all of that information, all of that giant list of tuples, and we have to minimize it so you guys can read it, and it looks nice. So basically, we take all the actions and the resources, we group them together. Any similar actions and resources, we group all of the actions and conditions, we group all the resources to which they apply together. And then we go, okay, those resources have a set list of actions, so we group those together, so it looks nice. Like I said, the generated policy might not always be compliant with AWS's constraints. Alternatively, if you don't want to minimize, you can use the JSON report. And the JSON report, in my opinion, is really where IAM Ape shines. Because not only it shows you a detailed report of all of your allowed actions, it also shows you a detailed report of all your denied actions, and in addition to that, it also shows you ineffective permissions. So ineffective permissions are permissions which are allowed in one place, but were denied either by a permission boundary or a deny statement somewhere. So let's go quickly over the JSON report. You can see it is divided by services, resources, and access level, read, write, etc., and all of the actions, and it shows you the ineffective permissions, again, with services, resources, access level, and what those permissions were denied by. So if you're trying to grant yourself access to an S3 bucket, but you're just not darn able to, this can show you why. All right, so everyone praise the demo gods. All right, so let's go with a quick demonstration. You'll have to trust me, bro, on this, because as you can see, this is the IAM Get Account Authorization Details report. It's very long and comprehensive. I had just generated this from my demo account. You can see it's very, 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 very long. But we'll just focus on these two users. We have an admin with MFA. So this user has an inline policy which grants him these actions: IAM wildcard, organizations wildcard, route 53, S3, and STS. It is an allow statement on all resources. He is also a member of the Enforce MFA group, and he has an attached managed policy. Let's take a look at the group. And the group is a simple deny everything on everything unless that user has AWS multi-factor authentication present. The attached managed policy is this statement, which allows all the not actions that we've shown here. So these are actions, these are not actions. Like we said, that means every other action is allowed. And again, resource wildcard. So let's just do this. We run IAM Ape. We give it the profile on which we want to query the AWS cloud, and we give it the ARN of the user that we want to get the effective permissions for. Hit enter, and then IAM Ape automatically queries your AWS account. Like I said, you can also just provide the output for the get account authorization details as an input, as a JSON file. And if the Wi-Fi here will just cooperate, let's give it a second. I do have a backup. That does not look right. Did you guys pray to the demo gods enough? Come on, I asked you nicely. All right, let's go with the backup. Let's go with the input. All right, no authentication. There we go. So this is the output that you should get. As you can see, we have a single statement which shows you that the effect is allow, the action is wildcard, resource is wildcard, and it has the condition of multi-factor authentication present, true. You can clap. Thank you, thank you. All right, and now let's move to the bucket user, which is a little more complicated. We have this bucket user. I'll go over it quickly because I see we're actually okay on time. So this guy has a couple of groups. He has IAM admins, he has bucket admins, and he also has this permissions boundary. This permissions boundary, this is its ARN. We'll go over it in a second. So let's take a look at the groups. He has no attached managed policies. He has no inline policies. Only these groups and this permissions boundary. So this group bucket admins grants him basically all of the S3 actions on all of the S3 buckets and an allow. He is a bucket admin, or a bucket user after all. The second group he has is IAM admins, which has an attached managed policy called AWM full access. That policy, let's take a look at that. The IAM full access grants him these permissions, IAM wildcard and some organizations, other API calls, which I don't understand why it needs them, but there you go. Thanks, AWS. And the permission boundary, let's take a look at the permissions boundary. Here we have a deny statement, which denies him access to my bucket and any resources within my bucket. It has an allow of, an allow not action for IAM and organization. So the permission boundary includes all actions except IAM and organizations, and the asterisk resource. So essentially, if we go through it in our mind, we can see that he should have access to most buckets except these two, this bucket and objects within it. And we can say that someone has erroneously added this user to the IAM admins group. Because as we can see in the permissions boundary, as we saw in the permissions boundary, he's actually not allowed to access any IAM actions or organization actions. So now let's run the command for that. And here we are. Wait, that's not the right one. I swear I can copy and paste. There we go. So he has the S3 actions and the S3 resource except that bucket and those objects. And as you can see, the IAM actions and the organization actions are not present. But this is the simple version. Let's go and look over the report a little. So if we go to the more verbose report, we can see that he had an organization's service permission on the wildcard resource. He had read permissions to describe account, but it was denied by the permission boundary. So that, in my opinion, is a really powerful and useful feature. Not if you agree.
Yes.
Thank you. All right. Thank you, demo gods, for giving me my backup. All right. So what is next? Basically, it's up to you. IAM Ape is an open resource, open source program. You can go to the GitHub and open issues, open pull requests, dive into the code, and please do because I need help. Some use cases for you guys. You can discover overprivileged users. So if you have a user, you look into its inline policy, it should not have admin privileges, but suddenly it has. That's a great way to discover that. You can find privilege escalation attacks. So if you are more of a red teamer, you want to find the effective permissions for a user that maybe you've managed to compromise the credentials for. There went my slide. You can analyze more effectively for privilege escalation attacks. You can minimize the amount of false positives you get. You can find out why the heck you can't get yourself permissions to access that specific bucket. And you can create a more comprehensive, more easy to read map of any users you have in your organizations. Some future plans for the tool. I do plan to add support for resource policies. This is something we haven't really touched about, but in AWS you can also give policies to resources. It is not something that is currently supported because there are just too many darn resources in your AWS account, and I am not going to crawl that entire thing. But what you will be able to do is just provide a resource policy or several resource policies as an input and have it evaluated as part of the entire chain. I also plan to integrate additional permissions gained by role assumption. Roles are resources which can be assumed by entities, and if a user has a permission to assume a role, he, not exactly automatically, but there's some conditions, he also gains those permissions. I do plan on adding this kind of sort of lateral movement, let's call it like that. Some integration with privilege escalation analysis tools. There are plenty of those out there. They are great. And more. As I said, it's an open source tool. I am very much open to suggestions and collaborations and more and more and more. And that is my time. So thank you very, very much. Yeah.
I have one thing as a suggestion. Do you plan to do the other way around, meaning like I want to locate someone who can actually do this specific API call against my entire environment? Meaning like I want to know if anyone can do KMS import key materials, crawl
Right.
the whole thing and see which one has it.
Okay, so the question was, just to repeat it for those who didn't hear, the question was whether I plan on doing like a reverse lookup to see if someone can access a specific API. That's I
Yeah, I
understand.
mean like if you know from some specific API that can be used maliciously, I want to be able to track with all the resources in all the roles, user and groups that in my environment.
Right.
Which user can do this specific API call
Okay.
based on the permission.
So that is not something that I'm planning on doing, but there are tools such as Iam Ape, which is a great tool, by the way. It's IAM but in code, which you can just dump the policies generated by Iam Ape into those tools, and they run a great search within permissions for that.
Okay.
Any more questions? Yeah, please.
Do you have any plans to integrate it with the?
Sorry, I can't hear you.
Do you have any plans to integrate it with the source code to see which calls the code is making to the AWS services and compare the IAM?
Sorry, again?
So, okay. So do you have any plans to integrate it with the source code to see like which calls the AWS calls have been the source code is trying to make versus like what policies that the user?
So like what your
What actually the service needs?
what the user actually needs versus what he actually has. So that is a bit of a more complex problem. AWS gives you this information only based on services rather than specific calls. You know, if you want to find out exactly which calls a user wants to make or does make, then you have to basically monitor the CloudTrail and see what API call he makes. But yeah, integrating the what services he has, then yeah, that's a great idea. Yeah, thank you. Thank you very much.